type of problem that we see often in this unit are the revenue problems. So let's read it together. The cost of a ticket to a hockey arena that seats 800 people is $3. At this price, the arena is sold out. A survey indicates that if the price is increased, attendance will fall by 100 for every $1 increase in the ticket price. What ticket price will result in the greatest revenue? What is the greatest revenue? Well, first of all, we have three distinct concepts: revenue, price, and tickets. Now, how do we get the overall revenue? Is if we multiply the price per ticket by the number of tickets, we get the total revenue. So in my case, revenue, which I can call R, equals price, which is $3, times 800. Now, let's see what happens if I change the price once. So one change in price will change my revenue equation. Because if I'm changing the price once, it means I'm increasing that price by $1. So 3 plus 1. And in terms of the number of tickets, I will lose 100 tickets for every $1 increase. So I'm going to lose 100 tickets. What if I apply two changes to the price? The revenue will become 3 plus 1 times 2, because I have two increases, times 800. Now I'm going to lose twice 100 tickets, so 100 times 2, because I have to apply it twice to the tickets as well. Now if I look to all three equations, my initial variable stays the same. The $3 price stays the same. The 800 number of tickets stays the same. The amount of the increase or the decrease stays the same. What changes is how many changes I apply. Well, if we can label these changes X, we can generalize our revenue equation, and it will become revenue equals 3 plus, now 1 times X is X, so 3 plus X times 800 minus 100X. And we have our revenue equation. When we are faced with an equation like this, we have a couple of options to solve this kind of problem. My revenue equation already looks almost in factored form. So my two options, I'm going to show you the two options, are: one, we're going to do it from factored form, and the other one from vertex form. And on the test, please choose the method that you are most comfortable with. Well, I know my function in factored form is y equals a x minus r x minus s. In this case, a does not really affect the number of changes in the maximum revenue. A, we use it more to decide how that parabola looks like on the graph. But when we were trying to find the x-intercept of a function, we were setting each equation to 0 and finding the x-intercept of that function, or the root. Well, what happens if we do the same thing to our revenue problem? So if I set the revenue to 0, right? So at this price, I make no money. I don't lose any money. I don't make any money. Let's see how many changes does it take to not make any money. So I have 3 plus x and 800 minus 100x. So what are the two roots? Well, one root is going to be x equals -3, Now, can I have negative changes? No, not really. I cannot have negative changes. I know that every change in price will be a $1 increase. And then for this other one, I'm going to set this whole equation to 0. And I have 800 minus 100x equal 0, or x equals 8. So it takes 8 changes for this hockey arena to make absolutely no money. If they increase their price to $11, then they run out of, they don't sell any tickets. They'll sell 0 tickets. So this number is not one that I desire. But somewhere between the -3 changes and the 8 changes, I have my axis of symmetry. I have the right number of changes that would maximize my revenue. Well, how do we calculate the axis of symmetry? We learned that if we average the two roots, so -3 plus 8 over 2 equals -3 plus 8 is 5, divided by 2 is 2.5. So my P is 2.5. So at 2.5 changes, I will reach that vertex point. I will reach the maximum revenue. Now, how do I find out the corresponding value to this number of changes? I have to substitute the 2.5 back into my revenue equation. So the revenue equals 3 plus 2.5 times 800 minus 100 times 2.5 is 25. Sorry, 250. My apologies. Right, so I have 5.5 times 550. So let's see what is that on the calculator. Times 5.5 times 550. The total revenue is $3,025. So, in order to achieve a revenue of $3,025, I have to make 2.5 changes to the price. So what will the new price be? Well, if the number of changes is 2.5 times $1, the price will be 3 plus 2.5 equals 5.5. Now, let's see how would we solve the same problem if we choose another method. Now, whenever I hear the words find the highest revenue, the maximum revenue, the optimal revenue, I always have to think vertex form. What form of the quadratic function shows me the maximum value of a function? Well, that is the vertex form. And right now, the revenue relationship is almost what looks like a factor form. So I have to expand it, simplify it, and complete the square. So let's first expand it. So 3 times 8 is 2400 minus 300x plus 800x minus 100x squared. So I will rearrange the equation from the highest power to the lowest power. So negative 100x squared. Negative 300 plus 800 gives me positive 500 x plus 2400. And now we are back to completing the square. Remember the last number in my trinomial, I always kind of park it and leave it to the end. Okay, so I don't want you to worry about the 2400 right now. We're just going to leave it. We're going to factor out the negative 100 out of the first two terms because that is our A. So equals negative 100, and then I'm left in the bracket with x squared minus 5x. Now, in order to complete the square, I need to add and subtract something inside the bracket. And we said that what we need to add and what we need to subtract is half of x's coefficient squared. So half of 5 squared. Now, so plus, what is half of 5? Is 2.5 squared. And then I have to subtract it as well. So minus 2.5 squared. Then I'm going to copy everything plus 2400. So now inside the bracket, I can already see my perfect square. The perfect square, remember, expanded is made out of 3 terms. So I have negative 100. My perfect square will be x minus 2.5 squared plus. Now, what is 2.5 squared? Let's see with the calculator. It's 2.5 times 2.5 or 2.5 squared is 6.25. So, sorry, minus. My apologies here. It's minus. So, minus 6.25 plus 2400. And as you probably remember from class, now we have to get rid of the square brackets by multiplying the negative 100 with each of the terms in the square bracket. So we have negative 100 times my perfect square, which is x minus 2.5 squared. Now negative 100 times negative 6.25 gives me positive 625 plus 2400. So what comes next? Well, I just have to collect now the 2 numbers. So I have negative 100 times x minus 2.5 squared plus 3025. So now, finally, my revenue equation is in vertex form. So let's see what the vertex is. Well, the vertex is given by the P, which is 2.5, and the Q, which is 3025. So the maximum value of that revenue is 3025. Now, let's not forget what the X represents. The X represents the number of changes in the price. So if I apply 2.5 changes to the price we said was 3 plus X. Well, 3 plus 2.5 is $5.5 per ticket.